Just going to give people a couple of minutes to find this room. Okay, welcome to NVO3. So we have quite a bijou meeting today. So this is the note well. I'll just leave that on the screen for a couple of minutes. Basically, it says any statement you make here is a contribution to the IETF, so please bear that in mind. Okay, blue sheets. There's one set going down each side of the room. Please sign those. We also have Iju doing the minutes. Thank you. So here is the agenda. 6 items on the agenda, including the working group status summary. Any comments on the agenda? Okay. We only have an hour and we have 6 items to get through, so we'll have to keep fairly closely to our time slots. Thank you. Okay, milestones. So I pushed back the dates of all of the milestones that we still had open on the charter, but we probably need to actually have a discussion on whether or not we need to add any new ones or remove anything. We'll probably take that to the list, but if anybody has any quick comments on the milestones, please come to the mic. Okay. So document status. So no new RFCs since the last IETF. We have 1, 2, 3, 4, 5. We have 6 RFCs in total. The data plane encapsulation. So our chosen standards track encapsulation document, Geneve, is now with the ISG. I think it's just completed IETF last call. I think the authors are just stressing there was an IANA comment on where to create the Geneve registry. We also have the NVO3 design team, encapsulation design team output. So we think this is probably ready for working group last call. If you recall way back a few years ago when we went into this process, we kind of decided that it would be valuable to publish the output of the design team, which was choosing between various tasks to choose between or make a recommendation on which encapsulation to take forward as a standards track encapsulation. And that had quite a lot of useful experience in, since many working groups have to grapple with this problem of picking an encapsulation amongst a number of proposals. So we will probably last call that shortly after this IETF. Has anybody actually read the latest version of this draft? If you have, please put your hands up. Okay, 1. Hopefully, running through working group last call will cause some more folks to review it. We also, in addition to our standards track encapsulation, we had some informational encapsulation drafts. So these were kind of some of the other options that were considered by the working group. The only one that's actually alive at the moment is VXLAN GPE, and that's on the agenda today. So what we originally said was once we had sent Geneve to the IESG, we would consider last calling as informational documents the other encapsulations. So like I say, that's on the agenda today. Our distributed control plane. So we have an EVPN draft that describes how to apply EVPN with Geneve. That's now with Martin. The virtual machine mobility draft. So this has been through working group last call a while ago. I owe it a document shepherd write-up. Though I found, when I read it, I found there are some editorial kind of nits that the editors are now working on. So I'd rather wait till they fix that, and then I'll post a review of it, and hopefully we can move forward quite quickly with the VMM draft after that. Somebody want to say that? Yeah. We have a lot of security drafts that Daniel was editing. These are currently individual drafts that have been presented. Some of them have been presented a few times, particularly the Geneva security requirements. We did try to adopt the Geneva security requirements a couple of times. Unfortunately, there's been a failure to reach consensus for working group adoption. I think we need to have a discussion about how to proceed with these drafts. If I can characterize, I think one of the concerns that caused a problem with adoption was appearing to put unrealistic requirements onto an encapsulation, security requirements that weren't necessarily implementable. That was at least one of the issues. So does anyone have any comments on how to proceed with these drafts? Like, we know that security is a major requirement, and it's something that we do need to address properly. And one of the reasons we went into this exercise of developing a set of security requirements and architecture and some proposals for protocol enhancements for that was because the security area does require us, and the security IDs do require us to come up with some security solutions and to address all the potential security issues with our encapsulations. Any comments? Should we just let this die then? Are there any operators in the room who are concerned about security in their data centers that would like to see this addressed? Okay, Martin.
Martin Vigoureux. No, I would prefer not to let this die. I know that's easy to say, not necessarily easy to make it a reality, but I would, and it's a pity that Daniel is not here, but I think we need to find a solution for that work to progress. We need, that's part of the commitments of that group, and Geneva is about to enter IESG, and if I promise the IESG that there will be some security aspects of Geneva coming after and that nothing comes, I'm kind of lying. So maybe ways to loosen some of those requirements, maybe is to make them, keep them, having them not optional, but optional to implement. I don't know. We need, I don't have the solution right now, but I would really like the working group to give it another try.
So, Martin, this Sam, we have tried. I think this is the second time we went through the requirements, security requirements effort, right? I think one of the major concerns is that the folks who wanted the security requirements or security aspects are very few in this working group. I mean, I believe it's across the routing area itself. It's not just this working group. So it's getting hard to really get the expertise of the security aspects to really come up with good requirements and solutions related to that. So it's a problem at large, but I don't know how to really tackle this.
So maybe I can reach out to my fellow security ADs to bring new blood, more blood. I don't know, has Daniel expressed any opinion on whether you would continue or leave that as is? No.
No, I mean, it's tried twice to get this through.
Yeah, I know.
To get this adopted. So,
okay, well, let's take it offline. I have an action point. If we can find someone on top of Daniel to push that.
Okay, NVO3 OEM. So we've had a number of drafts in the working group over the years, and for various OEM tools and for encapsulations based on the output of the routing area OEM design team, none of which have been adopted in the working group, unfortunately, and we haven't reached any kind of consensus so far on a common encapsulation for OEM. We have one draft on the agenda today, the BFD Genève, and I think the authors are going to probably ask for adoption for that. That draft has, I think, a number of encapsulations proposed in it. Greg?
No, actually, I'm not to interrupt you. I just
okay.
For no. If I just want to point is that there is a draft that we presented in Montreal. It's a result of collaboration of 4 authors, and it lists, I think, that even 4 possible encapsulations. And the purpose of this draft is not to be published, or not necessarily published, but to initiate the discussion in the working group and select preferably single encapsulation, because multiplicity of encapsulations in OEM, it's a headache and we should avoid it. So we should agree on one encapsulation for active OEM in Genève, and then all other documents will just follow and document it, and then their document that triggers the discussion can just disappear.
Okay, and finally on our Yang models, we have a common OEM, a common Yang model for configuration that's on the agenda for this meeting as well. Okay. So first up, I think we have the GPE.
Okay, Fabio Maino presenting an update on VXLAN GPE. These are the changes since version 06. We are at version 08. There were some minor changes done between 7 and 8, so this is the most significant. So what we introduced here is the concept of Shim headers. Basically, we reserve a number of protocol values. Or just to give the context, I mean, I think the group here is aware, but this is a way to extend the VXLAN encapsulation, basically with the protocol type that allows to include additional header after the VXLAN header. In a sense, it's similar to Genève, of course, as you guys know well. So we basically reserve a certain number of protocol values from 80 to FF to protocols that are defined Shim headers. These protocols have a fixed format, and the idea is that there are some functions that can be added to the protocol itself that may be relatively simple and can be stacked, right, one after the other. And for simplifying the parsing of these particular headers and to allow basically intermediate node to parse options that may not be known when the hardware that is designed for those particular nodes is designed. These headers have a fixed structure and can be easily skipped, even if they are not completely known. So this is the text that is in the actual draft in version 08. There were a few comments on the list suggesting to make a little more clear this one, and this is the changes that we will put in version 09, specifying that this is basically the reason why we want to introduce the concept of Shim headers here. The draft is referring to a number of protocol type that are defined up to now. As you see, the non-Shim headers until 7F are traditional and well-defined protocol. And the draft refers to GBP, group-based policy, and IOIM as protocols that are defined as Shim headers. I think that in the final version of the draft, the new this table should only report protocol types that are already assigned. So probably this table will be in the actual corresponding draft, but I mean, at this point is in there. And one comment in terms of applications that make use of this Shim header capability. My experience is that I have seen some people that are designing next generation of ASICs, and basically two applications that are well known and that have a chance to be in the next generation ASICs, at least in my experience, are the group-based policy and the IOIM. So I'm not sure if this is the right working group where this conversation could happen, but certainly one question that I hear is, okay, so while we are designing, and I guess Geneve is probably going through the same process, while we are designing the next generation of ASICs that support Geneve or VXLAN GPE, which options should I include? And typically the comment that I hear is that, there is a cost in allocating buffer for particular feature of the protocol. So if the feature is specified and standardized, then there is a better chance that whoever designed this component decides to allocate cost to basically support those features. So in my opinion, it would help if in some group, I don't know if it is this one or what it is, there would be some conversation on how to basically use this option. And this, I think, could be helpful as well for Geneve. And I don't know if you have a question. I can take it now or later.
No,
okay,
let's finish.
I'm almost done. So the next version, there are these comments that I have mentioned here that needs to be addressed. There is a companion draft of this one. We have a similar feature to VXLAN GPE in the LIS working group, and it's called LIS GPE, to no surprise. And I've got a few comments from the transport area reviewers that I think should be reflected in this draft as well. It's basically about transport implications and how to be compliant with RFC 885 about UDP encapsulated packets. So I think we should basically do those updates. And then, I don't know, I think one of the questions for today is, does it make sense to advance to this draft to informational, go through last call and do the due process? And this, I guess, is a question that we will discuss later. And that's it.
Okay. Thank you. Greg Mrisky, ZT. Two questions. First is that how active OEM to be encapsulated in VXLAN GPE? Because I think that it's a similar situation that there might be multiple ways to do it. You can use IP and then use destination port number to demultiplex known active protocols. It could be MPLS and use GAL label, and then have ACH and channel type to demultiplex. So you want it to be a multiplicity, or you will basically instruct implementers that you should use particular encapsulation method.
So what we define here is just the capability to identify a next protocol. And then, we define these Shim headers with a fixed structure. So when you parse the packet, you will find the type, the length, and basically the next protocol. So if you know about a particular protocol, you can go and parse further deeper. If not, you just skip to the next header and do it. For encapsulation of IOIM in particular, from the VXLAN GPE point of view, it's just one header. Then as long as the Shim headers respect this format of having a type, a length, and the next protocol field in the right position, then it's up to that document. I believe there is the author of...
Okay, my question was different. My question was not about IOM, but active OEM. So it's protocols like STAMP, BFD, ping, traceroute. So
those are OEM protocols.
Yes.
Okay. I think that there is a bit, right, and that is will be the there isn't a further protocol further down in the stack, right? That will be the last protocol carried it, and I think there is an OEM draft for OEM bit for that is used to identify that the payload of the actual VXLAN packet is an OEM packet.
What's the value of this bit? What it helps with? If, for example, demultiplexing is done by either UDP port or channel type in ACH, I really don't understand the value of this O bit for active OEM use case.
Okay, I think it was supposed to, to leave to the to this layer the capability to use this for OEM capabilities. I don't think that has been particularly developed a lot.
I think that the document will, or specification will benefit if it will be more deterministic and clear about what's the use case for OBIT, because otherwise it's kind of confusing.
Okay.
Another thing is that you have a protocol type VBNG.
Yeah.
So I can assume that it's for controlling user plane separation use case. So I would probably name it for CUPS or something like that, because controlling user plane separation not necessarily specific to VBNG. And VBNG, again, it's more accurately will be disaggregated BNG that uses it, because part of it can be a physical entities and part of it could be virtualized. So either it's DBNG or CUPS, because CUPS is more generic.
Yeah. In general, what VXLAN GPE does defines the wrap-up, right? Then what goes inside, it depends from the particular extension that one wants to define. So, yeah. And as I said, probably all those references will disappear because, they should be defined in the actual draft that is specifying what VMBG is or what GBP is or what whatever particular extension one wants to define.
Sam Aldrin. One quick question. I'm not security expert by any means. Just want to understand, because your draft doesn't address this, like how do you secure the payload? Like how exactly you carry the keys, and
in theory one could
do that?
So traditionally what is done in practice is using some form of IPsec whenever VXLAN GPE is carried typically outside of the data center. If you want to secure at the VXLAN GPE layer, right, what you could do is define one extension that is probably similar to the work you guys were doing for Geneve, that could provide authentication or could provide encryption of the rest of the payload. That is not addressed by the draft. Okay,
to
makes
add
sense.
that will actually help to understand how
That's
you
a good
can
idea.
actually do that. Thanks.
Yeah, thanks.
Frank Brockness, just want to go and echo. It would be a big help for implementers to go and see us allocating code points in some shape and form so that we can go and have at least harmonization across the current implementations. Whether we have this as an IETF work or not, I think if we have harmonization in some means, and the way to go and progress this, either as a kind of working group blessed informational or an AD blessed informational forward, maybe Ignas can go and give us some guidance from kind of his IESG perspective. I think it would be of benefit to us so that we at least get the implementations that are out there to use the same code points and help harmonization and interoperability. So I think it's a good approach.
I think you're referring to this slide.
It helps my document for sure.
Yeah, and I think it helps implementers. Yeah.
Remilio from Huawei. Could you go back to the modifications? Yeah. So here you mean that the tunnel endpoint, which is declared to support VIX-10 GPE, is that at least it should know the type and the length of the shim header so that it can skip it. So if a tunnel endpoint which does not recognize the type or length should not be declared to support VIX-10 GPE at all.
Yes.
Okay.
And the format is fixed, right? So basically, you know that even if you don't know what the actual shim header contains, you know that the first byte is the type, the second is the length, and the fourth byte is the next protocol. So you can skip while you parse it.
So the second question is, do you think the order of the shim headers matter? Because there is one draft, I think SAMI is a rough draft. I don't know its current status. It is basically it is an extension of the EVPN, which is used to negotiate the order of the different TLVs in Geneva. Do you think it is a firm requirement to VIX-10 GPE or not?
So, I mean, I think there is more flexibility today in the way hardware is working in terms of having some more flexibility in terms of parsing a header like this one. The more structure you can give to the header, the better it is for sure. I mean, it's hard to, and it's the same conversation we were having before, right? When you go and design some ASIC and you allocate some cost to support some of these features, which one do you support? So that is really, you know, the aspect that is relevant here. That's why, I mean, having the shim headers in front, one of the motivation is it helps, you know, designing and allocating buffer to handle those use cases. Ordering might be helpful. The problem is which is the order and what you do when you don't support in a certain order. If you have suggestion, yeah, that, I mean, can help. It's hard to say that A, B, C, and D should happen, and then right.
I'm going to cut it off after Frank.
Yeah, this is Frank again. I think it would be beneficial if we would be able to agree on an order. I don't think that we are ready to agree on an order. If you look at the lengthy discussions we're having for roughly 20 years on extension header ordering in V6, where it's still like, could I go prior to your header, please? Not sure whether that's a useful discussion to go and do it again here.
Agree, and that's kind of, I mean,
I'll just be brief. My personal comment would be is that it used to be very nice, lightweight, fixed header protocol, and now you are like Geneva and GUI.
Yeah.
That hurts.
I know. Thanks for the comment.
Okay. All right.
All righty. Thank you.
Right. So we have presenter.
And that might be also a discussion interesting for the security part. One of the reasons why it's so go back. Yeah, exactly. Why? How do you put something flexible into fixed size? Yeah, that's a good answer.
So let's talk about the base YAML model of NVO3. So just a brief introduction of this draft. First of all, the motivation. This draft is aimed to fill in the gap of the IETF NVO3. What happened? The IETF NVO3 YAML, and it is called a base YAML. Is that it is focused on the common and the reusable part of the NVO3 technologies such as VXLAN, NVGRE, Geneva VXLAN, etc. And it is designed to be compliant to the NVO3 architecture. And for the current status, this draft is adopted as working group document since September. And the version 00 is just re-upload with a change of the title, and for version 01, there's just some cleaning of the grammar errors. And okay, so here is just an overview of the NVO3 base YAML for people who are new to this draft. The basic idea is that we firstly define the VNI instances, and we indicate which interface, which NVE that this VNI instance is attached to, and multiple VNI instances can be attached to the same NVE interface. And the interface is defined in a way that we augment the interface YAML. And there are other features like the BGP control plane enabler and the peer NVEs and multicasts. And I won't go into more details here. So here is the result from the YAML validator now, and we have like 6 errors and 2 warnings. And for the warnings, they are not hard to handle, and for the errors, there are 2 errors about the keywords. I just realized that we have put it at the wrong place, and I will update them in the next version. And the other versions are all related to the same thing, which is the IETF BGP L3 VPN, because this draft is not an RC yet, but we augment this YAML in our draft to indicate which VNI instance is used as the L3 VPN, and the IETF BGP L3 VPN. This draft itself has been expired for now. And so for the next step, I don't know exactly how to handle this situation. Probably we should contact the IETF BGP L3 VPN authors to verify if they will keep working on the draft. If not, because this is the only L3 VPN YAML in IETF, so I think we are not. It is not easy to decouple from it. So I would like to the working group in this situation. If we go faster than this IETF BGP L3 VPN, will this cause a misdrive situation or something like that? Any ideas?
So if you have a normative reference, I mean, by definition, it's going to cause a misref.
Yeah, okay.
So,
okay.
Which is not really a problem. So it can be a problem if things end up, if there's such a dependency that there is some inaccuracy at the end of the day in your draft versus the L3 VPN one that eventually ends up being published. We can hold the draft and wait for the L3 VPN one before sending it to the ISG. It's usually the best way to proceed.
But in this draft, we just simply augment just one container of to add to this draft actually. So it is not that complicated in terms of technology here.
Okay.
Yeah. So do you have other comments regarding to the design here?
Who's read? If you could raise your hand if you read this latest version of the draft. No. Okay. I think it would be really useful to have some more review of this young model. So please, if you could review the draft and send comments to the list, that would be great. Thank you.
Thank you, guys.
Hello, this is Yizhou. I'm going to give a brief introduction on this loops, which is an ongoing effort happened in transport area, but we kind of think is relevant to NVO3 working group, especially when we talks about how to bind the functionality to the certain protocols. No, this one. Okay, there are a couple of use cases, but here I'm going to only talk about the most typical one. Thinking about, we are trying to use, we call it cloud internet overlay network, trying to use the cloud-based, not rather than the public internet-based WAN path to build a better path via the overlay nodes. The overlay nodes here means possibly some virtual machines created from the cloud providers over different geographical sites, possibly in multiple or single cloud. We did some experiments based on 37 such cloud, we call cloud routers globally. Then eventually we found there basically have 71% chances of finding a better path in terms of the latency. I'm not going to give all the data here. This is just to give a very brief introduction. So, but we found out there are still, the problems of the loss still exist, even with the selected path. So loops, the local optimization of path segments, the goal of it is trying to provide so-called local in-network loss recovery over specific segment or segments to optimize the packet delivery. So here the segments actually means the overlay hop. The local means over a single overlay hop. So the in-network loss recovery can be done either by the retransmission or by the forward error correction, FEC. So there are basically three fundamental elements of loops. The first one is the local recovery, the generic information model. And it can be encapsulated in a variety of formats. So this is where Geneve jumps in here. So Geneve could be a protocol that can embed the loops functionality. There are possibly some others like GIE, which GIE natively has already the sequence number, which is a little bit different from Geneve. Of course, there are some other elements of loops, like in order to make sure the retransmission happened in time, there might be some local measurement, and also in order to not interfere with the end-to-end TCP retransmission, there must be some congestion feedback. So ECN possibly can be used here. So how it relates to Geneve, there is a solution sketch. It gives the whole picture of loops function. For example, like the sequence space and how to determine the initial sequence number and how to generate the acknowledgements, whether the nag or positive ACK should be used, whether the selective ACK should be used, and if the forward error correction is used, what's the structure of it, and how to detect loss, how persistent the retransmission should be, only retransmit for once or retransmit for a certain amount of time. All these are actually more like the transport technology related. So that's why this work is in transport area. If you are interested, you can look at the draft here. But of course, it comes to the encapsulation eventually. So the Geneve binding should define the format when embedding the loops to Geneve. So basically, it tries to map the functions to Geneve, define the data plane format. Also, there are possibly some Geneve specifics that need to be taken care of. For example, the Geneve has a mandatory field called the VNI. How to set this value? There are possibly I remember there is a C bit, which is a control bit to indicate it's more like a control message without payload in Geneve. So there are possibly some specifics. So there is a draft which can be served as a starting point for this mapping, the function mapping. This is a proposed loops option. I don't think we should go to too much details here because it's a very initial version, and we haven't reached the stage that we have a broad consensus on what kind of functionality the loops should achieve. So, but this is just to show that in order to embed the function of loops, we possibly need a namespace for it, and we need tags to indicate like the packet sequence number, and also some flags to indicate whether timestamp is there or ACK number and the different information for acknowledgement. The things like that. It has to be defined eventually. So just for your information, loops had above in last IETF meeting in transport area. There was some feedback showing that the standardization was required. So if you are interested, you can see the slide deck from last meeting. So we are going to discuss in more details for the design issue, which including the encapsulation and possibly some other issues. But I guess the encapsulation might be of interest to NVO3 attendees here. So the people might be interested, including the transport protocol designers and the tunnel protocol designers, and of course, FEC experts. So if you are interested in this, you are welcome to join us tomorrow morning at Room Orchard. And there are some drafts available specific to Geneve. There is an encapsulation. So if, you are welcome to review it. That's all.
Okay, any comments? Okay, thanks.
Hello, everyone. I'm Shami from ZTE. This presentation is on BFD for Geneve. We have updated this draft to the Roman version. In the latest version, we use NVO3 official terms to substitute some unofficial terms. This figure specifies the relationship between these well-defined terms. NVE means virtual new network virtualization edge. It represents the Geneve tunnel endpoint. TS means tenant system. It represents the physical or virtual device attached to a Geneve tunnel endpoint. VIP means virtual access point. It represents the NVE side of the interface between the NVE and the TS. Three options for BFD over Geneve are defined in this draft. This is the first one. When Geneve tunnel is used to carry Ethernet frames. This packet format will be used. We can see within the outer UDP header, the well-known destination port 6081 is used to indicate the Geneva header. And within the Geneva header, the protocol type is set to the value to indicate the Ethernet frame. And beneath the Geneva header, there are in the Ethernet header, in the IP UDP header, all the fields beneath the Geneva header will follow the format and the value set that's in draft IETF BFD VXLAN, which is already in ISG processing. This is the second encapsulation for BFD for Geneva. When Geneva tunnel is used to carry IP packets, this packet format will be used. We can see within the UDP outer UDP header, destination port is the same with the previous one, and within the Geneva header, the protocol type will be set to the value of IPv4 or IPv6, and immediately follow the Geneva header, there is the inner IP header. The source IP of the inner IP header will be the IP address of the VAP of the originating MVE. And destination IP will be the IP address of a VAP of the terminating MVE. And the IPTTL must be set to 1 for the inner IP header. And beneath the IP header, there's a UDP header. In the UDP header, there's a well-known destination port 3784 used to indicate the BFD control message. This is the third one. When Geneva tunnel is used to carry MPLS packets, this packet format will be used. Within the outer UDP header, it's the same with the previous two. Within the Geneva header, the protocol type will be set to the value of MPLS. And beneath the Geneva header, there are MPLS interface context label, the MPLS scale, and the MPLS GACH. MPLS scale is a special purpose label, certain label, and the MPLS GACH should be set to the value 0x0022. That's requested by RFC 6428. And among them, MPLS interface context label would be used to identify a VAP of the originating NVE and the VAP of the terminating NVE. During the discussion on BFD for VXLAN on a mailing list, a question was raised, should we allow multiple BFD sessions for one VNI? This figure is derived from NVE reference model of NVO3 architecture, IFC 8014. I think from the NVO3 architecture point of view, we should allow multiple BFD sessions for one VNI. As we know, VXLAN GPE is also a data plane solution that's developed, adopted in NVO3 working group. So a question raised here, do we need to add some notes saying its applicability to VXLAN GPE? Because comparing the Geneva encapsulation with the VXLAN GPE encapsulation, we believe that the mechanism described in this draft can also be applied to based on GPE. So we think this draft is already stable, so we ask for working group adoption.
Sam Aldrin. I have question, like, why do you need those 3 types? This is Geneve, BFD for Geneve, right? The second option is good enough. Why do you have to come up with another? Either you're not clear what is the right one, or is it something like you cannot make up your mind?
Geneve is a multi-protocol. It can carry multi-protocol payload. So
Sure, but you're talking about BFD for Geneve.
yes,
It's not about payload. It is about for Geneve.
but in this draft, BFD sessions are originated and terminated on VIP. VIP is the NVE side of the interface between NVE and the TS. So for different payload, the VIP will use different encapsulation for the BFD. There's different kinds of VIP,
Greg Mirsky, ZT. I'm co-author on this draft, and I think that yes, it might be that some implementations of Geneve will do load balancing based on the payload, though I think it's not likely. When we started this work, there was no draft on possible encapsulations of active OEM. And I think that probably the better outcome would be is that if working group decides that active OEM should use one particular encapsulation across all active protocols. So, and that, as I mentioned earlier at the mic, is the purpose of draft that we have now on listing all possible OEM encapsulations.
But my personal opinion is that for different kinds of VIP, the different payload will be carried in Geneve tunnel. So for BFD, we also need to test different kinds of payload of Geneve tunnel.
Again, BFD specifies RFC 5880 that it monitors the path between 2 systems, and to a certain extent the forwarding engine on the on the systems that host BFD application. So yes, if we use different encapsulation, we will have some benefit of verifying that this particular encapsulation is working somewhat. But at the same time, the problem would be is that how 2 endpoints agree on which encapsulation use if multiple encapsulations can be supported. So there is,
I think
there is something to discuss, I think.
I'm not aware of any dependency between the encapsulation for BFD in other areas where we use BFD over tunnel, some kind of tunnel, like an MPLS or in pseudowire. I'm not aware of a dependency between how you encapsulate BFD and how you encapsulate the payload.
Right. So I think in the interest of time, right, what we need to do, if, for example, take MPL, the solution number 2, if you are saying that that is not going to solve the problem irrespective of payload type, I think there is fundamentally something wrong in how we are actually designing BFD. Yeah. So I think that the solution, right? So we need to really think through, it's not going to be payload type. There is a protocol for the data plane header.
Yeah, I want to suggest one point, just one point. The BFD over Geneve is different from the underlay BFD. So if we run BFD between the NVE just for underlay test, we can use just one kind of encapsulation because it's tested the underlay. But if we want to use BFD for Geneve, actually we want to test the overlay. You know,
Correct.
it's a tunnel. So the different tunnel payload maybe should use different BFD encapsulation. So that's the point.
So maybe
Yeah.
I think you should really come up clearly, like, why do you need different types of BFD in different use cases? I think, and we are talking purely about overlay. We are not talking about underlay. Okay. Why do we need that? I think if you can make really good call on that, then we can discuss further on that.
I think the thing is that in other cases where we have another VPN technologies, say pseudowires, if you have an Ethernet pseudowire or if you have an ATM pseudowire, you don't have a different BFD encapsulation for VCCV BFD for those different types, but they're completely different technologies for the what in that case is the virtual connectivity.
Right. So basically, because we are monitoring the pseudowire itself, not the service.
Correct.
Right. So I agree. If we are monitoring Geneve tunnel, then we need to be clear that we're monitoring Geneve tunnel, not their any extension to the tenant.
Well, are we monitoring the Geneve tunnel or are we monitoring the VNI, the connectivity for the VNI? I think one of the issues here is maybe that the layering here is not very clear. The OEM architecture is not really that clear, and maybe that needs to be clarified somewhere, either this draft or in the OEM requirements we've got, or some sort of OEM architecture draft. So when we say we're monitoring Geneve, what do we mean, and on which layers do we inject OEM?
Okay. We had very good discussion about what we're monitoring in course of working through BFD over VXLAN.
Mm-hmm.
And actually what we agreed is that in most cases, monitoring VXLAN on one of VNIs may be sufficient. But at the same time, there is a clear interest of being able to monitor separate VNI. So, but again, at the same time, it's orthogonal to the question of how we encapsulate BFD packet into their overlay tunnel. So it's only was the discussion of whether we allow multiple BFD sessions between two endpoints.
But the difference is that for VXLAN, we have just Ethernet frame as the payload. But for Geneve, we have different kinds of payload.
Yes, we may have different kinds of payload, but again, unless we know of the cases where some implementations will look at their Geneve payload to do ECMP, I think that there might be a little value of documenting and standardizing multiple encapsulations for active OEM. Because if like in IP, so there will be done on outer encapsulation, then their OEM will be sharing fate with their payload, with the data traffic. So regardless of how active OEM is encapsulated. So, and again, their validation of their decapsulating side of their tunnel is really limited if we use specific transport encapsulation for BFD packet.
We are technically out of time now on this one. Maybe we can move on to the next draft and take it to the list.
One more question?
Okay.
Okay, Remedy
We are out of time. Sorry.
Okay. Okay, this presentation is about performance measurement for Geneve. So the mechanism is similar with the previous one. when we discussed the BFD for Geneva, we realized that we need to do performance measurement also for Geneva tunnel. So this draft specifies the performance measurement method of Geneva tunnel. And performance measurement includes packet loss measurement and delay measurement. So you can see this encapsulation is similar with the BFD for Geneva, but the difference is that for the inner UDP header, within the inner UDP header, we use the destination port 862 to indicate the stamp test packet. STAMP is a IP performance measurement protocol that's developed in IPPM working group. So we use STAMP to achieve performance measurement when the Geneva tunnel is used to carry Ethernet frames. This is the second encapsulation. It's also similar with the BFD for Geneva, and we use STAMP to achieve the performance measurement when the Geneva tunnel is used to carry IP packet. This is the third one. Because for MPLS, loss measurement and the delay measurement, they use different test message with IPPM. So in this encapsulation, we use test messages defined in RFC 6374. That's for MPLS loss delay measurement. So beneath the MPLS encapsulation, there is a test message. It can be loss measurement message, delay measurement message, or combined loss delay measurement message. And it's differentiated by a different MPLS GACH value. These values 0x, 000A, C, and D were requested by the RFC 6374. And among the MPLS encapsulation, MPLS interface context label will be used to identify a VIP of the originating NVE and the VIP of the terminating NVE. So it's also similar with the BFD over Geneva. So next steps, we want to ask more review and comments and revise this draft to improve it. Any questions?
So, yeah, I actually have more of a question for Martin on charter and scope of the working group. So it seems that in the context of these OEM drafts, you're trying to monitor the service, almost tenant system to tenant system connectivity. No? Or yeah? Otherwise, why do you care about how you're in?
Test the tunnel, Geneva tunnel.
No. But that you said you were monitoring the service.
No. In this case, we're not monitoring the service. In this case, we're just monitoring the tunnel, and it helps to basically to understand the whole. For operators, it's useful because then they can understand which part of overall path to the tenant system contributes most to certain, if they experience, service degradation or something, then they can separate what's contributing by their performance in the tenant system versus their tunnel. So no, performance is clearly for their tunnel.
Okay. So the previous draft was service monitoring.
Not really. No, it's not service per se, because it's not BFD session between tenant systems, because BFD session between tenant system is undistinguishable for their Geneva endpoints. For Geneva, it doesn't differentiate between tenant data and BFD session between tenant systems. So again, the previous draft, again, it monitors their tunnel. And if there is a multipath in underlay, then they can run, and if they know how the VNI is being placed on different underlay paths, they can use some intelligence to monitor particular paths through VNIs. But idea is that BFD monitors continuity of Genève tunnel between endpoints of the tunnel.
So, I mean, like maybe I'm not clear. If you're monitoring the NVEs in this case, right, the edge where the inner end cap is going to happen, decap is going to happen. So, why do you care about what kind of payload it is carrying? After Genève header, right? If you can pop the BFD packet to the IP port, so why do you really care about what the payload is going to be?
Yes, I think it's a legitimate question. And again, as I mentioned, and probably that's something that we need to talk with Shim offline. Again, if we know that underlay network doesn't use the payload to do hashing and load balancing, then it's absolutely irrelevant. If it does use payload for the load balancing, then there is some value in using the same encapsulation, because then you can use certain algorithms and certain methods to try to monitor a particular path. It's again, it's a similar to how you do BFD over IP MPLS network. Okay, so if their underlay, so if you use their IP encapsulation, IP information from their LSP payload to do load balancing, then you can use the combination of methods to run your BFD session and monitor particular path in your multipath environment.
I mean, at least in the virtual world, right? None of the transit devices know anything about the inner payload. So the load balancing issue doesn't arise based on the payload. I think that is given at least from the NVO3 architecture document, if you can look at it.
Well, again, I think that if we use definite normative language saying that you must use this information for the load balancing in underlay, and it will be outer encapsulation, I think that will be very beneficial, because it will make certain that inner encapsulation has no any impact on choosing their path in a multipath environment in the underlay.
So I think if you, at least the architecture document doesn't talk anything about the transit devices. Maybe that's a choice we have taken beyond me to answer that, but I think at least from what we have is that the transit devices do not play a role in terms of what the inner payload is going to be.
I think the benefit is
because as simple as this, if I secure my inner payload, there's no way they can actually look it up. It doesn't matter what kind of payload it is. And by the way, like by default, everyone actually secures the packet, inner packet.
I think the benefit is that we can use this to test the encapsulation and the decapsulation of different kinds of payload, Genève tunnel.
Yeah, you can do that without having the payload of different types. Just the header should do.
Just header.
Yeah.
But we need to run a BFD session.
Sure, NVE to NVE.
Yeah. Do you mean?
Because all NVEs talk IP, right?
As I said, just the underlay BFD is different from the BFD for tunnel. Yeah.
Sure. So all I'm saying is you're running BFD session from tunnel endpoints, not the tenant endpoints.
You may just need underlay BFD?
No, I'm talking about tunnel endpoints with the overlay BFD.
Yeah. So this is just the draft describes.
That's correct. So what I'm saying is you don't need those three different types. Rather, you can achieve with just one type, which is IP, which is type 2.
You know, in previous meeting, we also have suggestion to just MPLS encapsulation.
Actually, to the point of IP, I think that in the meeting before Montreal, we had a discussion, and use of IP is probably suboptimal for encapsulation because it creates a significant overhead and moves the BFD packet out and possibly out of their fast memory. So that's why effectively probably MPLS encapsulation is the most efficient for the Geneva.
I think that's a bit of a generic statement to say it moves out of the fast path when, as far as I'm aware, the vast majority of LSP BFD implementations are just encapsulating it in a UDP header.
Well, LSP doesn't have the overhead of, imagine that we have IPv6, then we have Geneva, and then we use IPv6 inner encapsulation for BFD. Okay, LSP doesn't have any of that.
Not all virtual stacks speak MPLS, but they all speak IP.
Okay, that's a good point, and that's why we have the draft which lists of options, and we really appreciate the discussion about it.
Yeah, great. So I think it'd be really good to have some more discussion on the list in general and some feedback from the working group in general.
I think that if Sam will share his views as expert, not as a chair.
As explicit as possible, so I think you should take it.
No, but yes, let's do it on the list, because if you post it on the list, it will trigger discussion and people will think. Okay, but thanks for your input.
All right, I'm going to close the meeting there. Thanks very much, everyone. We're running 10 minutes over. Thank you. Blue sheets. Does anyone know where the blue sheets are?
Hasn't signed yet?
Oh, you have the blue sheets.
No, we need to have more discussion. More discussion.